Probability affects us every day. In fact, what's the probability that you're going to enjoy this video? 100%, of course. In general terms, probability is used to determine how likely something is going to happen. It is dictated as a numerical value between 0 and 1. Probability is a fundamental part of our lives that can be seen in occurrences such as weather planning, traffic, sports, stocks, and forensic science. The probabilistic approach to forensic science is the idea that aspects of forensic procedures can be quantified. Probability is used to assert the likelihood of an occurrence at a crime scene or connecting a suspect to a crime scene with a high degree of likelihood. Probability is used in DNA profiling to assert the rarity of an individual being included as a genetic contributor. A forensic scientist can make the claim that a suspect is included as a contributor to the DNA evidence found at the crime scene. The probability can be expressed as 1 in 400 non-million, indicating that it is very unlikely that another individual has the same DNA profile. This number is found by multiplying the probabilities of each genetic marker shared between a suspect and a DNA sample found at the crime scene. This is known as the product rule.
In court, probability is important when convincing a jury that a suspect is connected to a crime. This also helps to reduce the chances of an innocent person being convicted. A 1 in 4 chance of individualization is much less probative than 1 in 10 million. Keep in mind that the population of Earth is more than 7 billion people, so a probability of 1 in 10 million is not probative enough to claim that a suspect is connected to a crime. Fingerprint science is one form of biometrics, which is a science that utilizes people's physical or biological characteristics to identify them. This means that the probability of 2 people possessing the same fingerprint is extremely low. This low probability provides probative value to fingerprint comparison evidence. Fingerprint science operates on the assumption that every fingerprint is unique. Nobody has the same fingerprint. Not even do identical twins have the same fingerprint. Forensic science professionals have always aimed to convey their findings accurately and reliably. Critics of forensic interpretation claim forensic experts are not reliable because they cannot provide a numerical level of confidence to their conclusions outside of DNA. Probabilistic approaches would quantify the error involved in human judgment and would put a numerical value on how probative a piece of evidence really is. This would provide more certainty to a forensic expert's assertions in court. Assigning a probability to error can be done by utilizing proficiency testing. In forensic science, proficiency testing is used as a tool for monitoring ability to perform work in a specific discipline or task. We can get an idea of how frequent mistakes are made by testing every examiner. This is time-consuming and has to be done for each examiner. This could lead to case backlogs and fatigue. In addition, testing does not yield results representing forensic practice as a whole.
Placing a numerical value on confidence is done by using Bayesian statistics. Bayesian statistics involves using the dependent probability of events to generate a probability score. This score can then be attributed to comparison evidence, like fingerprints, to determine a degree of matching between 2 prints. The issue with using a Bayesian model for forensic evidence is that there are so many factors involved with the creation of forensic evidence. For example, in fingerprinting, we would need to take into account things like contact pressure, surface texture, skin oil characteristics, and more. Research into these areas would allow us to develop values for our Bayesian model. However, the necessary research for these aspects is minimal in nature. Until we have sufficient understanding of these variables, we cannot reliably utilize the Bayesian model in forensic science. In all, the current probabilistic approach is inefficient since our understanding of how evidence exists is limited. However, a Bayesian approach may be beneficial if we acquire a better understanding of factors involved in the establishment of forensic evidence.